Uh, Dear students, good evening. Today we are going to start operating system. Here are the outlines. These are the outlines. What is what operating system do? Systems do. Computer system organization, computer system architecture, operating system structure, operating systems operations, process management. We have studied this chapter in detail, how to manage processes, and then memory management, storage management, protection and security, distribution systems, special purpose systems, computing environments, open source operating system. Here we need to cover some chapters like memory management in detail, then storage management in detail, protection, security. But here in this today's presentation or lecture, I'm keen to give you a walkthrough of all these chapters in a few limited slides. After this, once these 20 slides get finishes, so after that I will teach you individual chapters in detail. Okay, so I hope you are with me, and please stay with me. It will be fun to study or to learn these things. So let's go to the objective. Okay, so objectives. Objective we have to provide a grand tour of the major operating systems, system components, to provide a grand tour of the major operating systems components. Yes, in this lecture I would like to give you a grand tour of the major operating system components, and then I will be giving you I will be providing you coverage of basic computer system organization. Okay, so let's go to the first slide. So what is an operating system? Yes, what is an operating system? A program that acts as an intermediary between a user of a computer and the computer hardware. Yes, it works as a intermediate module between a user of a computer and the computer hardware. You know, one can't use a machine or hardware without the operating system. So once when you get installed the operating system, after that your machine gets usable. Okay, so that is why operating system is very important. Operating system goals. What are the goals of operating system? Why we need to install operating system? Execute user programs and make solving user problems easier. Yes, to execute the user programs which have been installed by the users or user, and make solving user problem easier. Yes, and to make it easier for the user to solve his or her problems. Okay, make the computer system convenient to use. Yeah, with the help of operating system, normally we are able to use the computers in a more convenient way, and then use the computer hardware in an efficient manner. Yes, to use the computer hardware in an efficient manner. Okay, so computer system structure. Before teaching you this slide, I would like to go to the comment section to see any comments, any questions from the students I have in this session with me. So yeah, I have some students. Okay, I will give you the slides in the group. Okay, guys who are with me, particularly Shahzad, Wasim Hadri, what I'm doing today, I'm very keen because we are having an exam right after 1 or 2 weeks. So today I thought to let's have a complete walkthrough to give you a tour of operating system. So in this slide, within each one or two slides, I'm explaining a big topic briefly. Why? So that you can have at least a brief background of operating system. Why I'm doing like this? Because you are not having enough time to learn or to study or to teach you each and everything right from the basics. So far we have studied 2 or 3 chapters, and still I'm trying to cover at least 2 2 chapters in the remaining 2 weeks, but it will not be easy. So that is why I thought, why not to have a brief tour of each chapter within a few limited slides. So in this lecture I have 19 slides, and within these 19 slides I'm giving you a tour of each chapters, just by explaining that complete chapter within a few words, on a few limited slides. Okay, I hope you have got the objective of today's lecture. Okay, so computer system structure. Computer system can be divided into 4 components. Yeah, we all know that that is hardware, provides basic computing resources, that is CPU, memory, and IO devices. You know, IO devices, input or output devices. Operating system. Operating system controls and coordinates use of hardware among various applications and users. Yes, you know what operating system does? It controls and coordinates use of hardware among various applications and users. Application programs, the programs, the app, which are normally installed by the user, define the ways in which the system resources are used to solve the computing problems of the users. Yeah, you know, when we install the operating system, so with the help of operating system, normally users installs their app, their application programs, application software, and then they normally use those application software for their personal objectives. Let's suppose accounting software, and there are a lot of softwares which are normally used for weather forecasting, animations, games, movies. There are a lot of different types of application softwares. Okay, so such as word processors, I have named a few of them. Word processors, compilers normally used to compile a program. I hope you know programmings like C, C++, Python, and Visual Studio, .NET, Java. There are a lot of languages, R language. Okay, so web browsers, yeah, web browser is also a type of web application, a kind of web application, yeah, web program. And database system, yeah, database system is also an application software. Video games, as I already said, that video games is an application program. So all these things, you know, comes in the application program, and this is a basic component of operating system. We have 4 components of operating system, that is hardware, operating system, sorry, 4 components of a computer system, that is hardware, operating system, application programs, and user. These are the 4 basic components of a computer system. Okay, the last one, users, people, me, you, we all are users, people, machines, and other computers. Yeah, machine can also be used as a user on a network, and other computers, yeah, so these, they are called users. Okay, okay, let's go ahead to the next slide. But before teaching you the slides, I would like to go to the comment section to see any comment from students. Into 3 parts: software, hardware. Isn't it will yeah, different operating system have different techniques. We problem solving a process execution. So okay, I have received a bunch of questions, so let me explain each of the questions. So sir, different operating system keep a different algorithms maybe. No, even in different operating system, more than 70% scheduling algorithms are the same, or most of the algorithms are the same, and yet we are in search to how to say, to innovate new algorithms, to discover or to have some more research for finding more algorithms for operating system. So all of the operating system uses most of the common algorithms. I mean most of the 70 more than 70% algorithms are used by all the operating system. This is what I mean. Okay, let me take the next question. Different operating system for different techniques we problem solving a process execution. The same thing again. Different operating system have almost more than 70% algorithms in common, and they may use 5 to 10% algorithms which differs from each other for solving for executing any process. Okay, then the next question is, So isn't the CPU divided into three parts, software, hardware, or user, where software is further divided into operating system and application programs? No. Uh, it would be better if you use the word computer system here instead of CPU. The computer system is divided into four parts. That is hardware, software. Here, see, these are the four components. Okay, normally users, application programs, and then operating system and computer hardware. As I taught you, you see hardware, operating system, application programs, and then user. This is the structure of computer system structure. Please don't, it would not be better if you use the word CPU here instead of computer system structure. Okay, so let me go. Okay, application programs. Okay, sir, the final chikam taso will exam no agi ke ho sir the chapter 2 algorithm chi hui paki aga or bia chikam us taso teach ka with the final ke include hui, right? Okay, this guy is talking to me in a local language, and what does this mean? He's saying that, sir, very recently we have finished chapter 2, and whatever I'm teaching right after chapter 2, so he's asking me what will be included in the exam. Chapter 2, whatever I'm teaching after chapter 2, and whatever I have taught before chapter 2, including some chapters, one or two chapters, which are at least one chapter which are taught before chapter 2. Okay, sir, the kernel, that's partly kernel is a part of operating system. Okay, normally if you remember, we discussed kernel processes or kernel threads and user threads, user processes, user mode, kernel mode. We have already discussed all these things. So yes, it is the part of operating system. It is not a kernel is not a part of hardware, and kernel is not a part, or it is not itself an application software. In fact, it is a part of operating system. Okay, guys, if you have more question, please don't shy to write it down here in the comment section. Let me go to the lecture, to my PPT, to my slides back, and I will come here gradually with the passage of time to read your questions, okay, and to answer your questions. Okay, so four components of a computer system we have. This is a user component. All of the users which are using operating system with the help of application softwares or application programs. Text editor, assembler, compiler, database system, all these are application programs. Okay, you may call it also system programs. Can you please switch on the lights? Okay, and then operating system is the third part of computer system, and then computer hardware. It is the fourth part of computer system. Okay, fourth part or fourth component of computer system. Let's go to the next slide. So operating system. Okay. Believe me, I have covered several chapters of operating system, but yet some students, they struggle with the definition of operating system. So today I thought to mention a brief definition of operating system again for you guys. So how we can define an operating system like this? Okay, OS, operating system, is a resource allocator. Yes, it is a resource allocator. It allocates a resource to you guys, to users. Okay, manages all resources. With the help of operating system, you are managing all the resources, IO resources, printer, scanner, CPU, memory, all of the things which are inside computer system are connected through computer. I mean, peripheral devices are connected with computer from outside. Okay, outside. Decides between conflicting requests for efficient and fair resource use. Decides. Operating system decides. It avoids deadlock. It manages conflicts. Like when a process, also at the same time when two different processes ask for the CPU, or when they creates a conflict between or among IO devices. So this is what this line means. So who manages these kind of conflicts when the processes ask when different processes ask the same resource? So it is only operating system who solves such conflicts. Okay. Then okay, OS is a control program. OS is a control program As I already said, it manages, or in other words, it controls execution of programs to prevent errors and improper use of the computer. Yeah, our operating system helps or manages to recover from errors, or it manages to avoid errors, or it prevent errors, and it also manages the computer system not to be used improperly. Okay, not to be used it improperly. Okay, so this is what operating system does. This is how operating system can be defined. Okay. Okay. Let's go to the next slide. Mm, and before teaching you the slide, I would like to go to the comment section to see any comments from the students, so that okay, no comment here again. Okay, so let's go back to our slides. Okay, operating system definition. Yet we are having on operating system definition on this slide as well. On this slide, no universally accepted definition. Yeah, there is no universally any universally accepted definition for operating system. This is what this line means. Everything a wonder shifts when you order an operating system is good approximation. Okay, when you order an operating system, so whatever the wonder he ships you, so that is a good approximation for you. You may think that as an operating system. Okay, but where is wildly? Oh, yeah, this you mean it varies from wonder to wonder, because there are different flavors from different companies. So this is what it means, that it varies widely. The one program running at all times on the computer is the kernel. Yeah, this is the program. I hope. What is the name of that guy? Shahzad. He will be with me. He just asked this question about kernel a couple of minutes before. So this is here we are now studying kernel. If you are here with me, so please be attentive. Okay. The one program running at all times on the computer is the kernel. Kernel is the program which is always active and run on the and runs on the computer system. Everything else is either a system program ships with the operating system, or an application program. Okay, everything else is either a system program ships with the operating system, or an application program. Okay, besides kernel, so you may think that every other thing or everything else is either a system program or an application program. Okay, but kernel is not an application program, it is a part of operating system. Okay, sorry guys, I have a juice, and it has a lot of, it has a, how should I say, it is having a kind of digestive gas, so that is why. Okay, computer startup, bootstrap program is loaded at power up or reboot. Okay, when you power up your computer system, so the bootstrap program load. Okay, this is how computer starts up. Okay, so the title of this slide is computer startup. So bootstrap program, it is a program which is normally loaded at the power up, or when you reboot. Reboot means restart. So when you restart your program, or when you power up your program, so the bootstrap program is loaded. Typically, and it is typically stored in ROM, read-only memory, or EPROM, erasable programmable read-only memory. This is what EPROM stands for, generally known as firmware. We also call it firmware because on ROM we can erase and reprogram this ROM. I mean, we can embed software on this chip, so that is why it is called firmware. Okay, initializes all aspects of a system. Yeah, bootstrap, what it does, it initializes all the aspects of the system. Okay, and then loads operating system kernel and starts execution. Yeah, bootstrap, it loads the kernel and then starts execution. Okay, and then the execution start. Okay, computer system organization. Okay, let's go back to the comment section if we have any. Sarda bootstrap wani last zal se khas na pe shave. Okay, Shehzad is here with me, and it's very good. Wonder in Urdu we say the dukandar, the person who normally sells or shifts operating system, the person from whom you buy the operating system, or the person who normally delivers the operating system to your home. Wonder. The you may, in simple words, you may call him developer. I'm not too confident with the word developer, but you can say the developer or manufacturer. So this is what Wander means. Okay. Wander ships. I hope you have understood Wander. Wander is the company, is the shop, or the person who normally delivers the operating system to you. Okay. So in simple words, manufacturer. Okay. And then you have asked about another thing, that last time you couldn't understand the meaning of bootstrap. Bootstrap is a program, and it is normally present, or it reside inside a chip, and we call that chip, and that chip is called EPROM, erasable programmable read-only memory. It is like a ROM read-only memory. You can only read it. And when you switch on, when you powers up your operating system, what happens? The bootstrap program, it loads from the EPROM, and then what happens? It loads, and it also, I think on last slide here, loads operating system. The bootstrap, it loads operating system kernel, yeah, and it then loads the kernel and starts execution. Okay. So with the help of bootstrap, you can only load the kernel. Otherwise it's not possible. Otherwise computer would never know how to load the operating system. So only with the help of bootstrap is a program. You may think it of a mini app, but it is a program. Okay. Embedded program on a chip. Okay. So that is why it is called firmware. I hope you would have understood. Computer system organization, computer system operation. One or more CPU device controller connect through common bus, providing access to shared memory. Computer system operation, yeah. So computer system organized. This is how a computer system is organized. You see, memory, concurrent execution of CPUs and devices competing for memory cycles. Okay. One or more CPUs, yeah, we may have one or more CPUs, device controllers connect through common bus, providing access to shared memory. Yeah, this is shared memory. And we have USB controller. We have different controllers: disk controller, USB controller. We have graphics adapter, VGA, visual graphics adapter, and we have CPU. We may have one or more than one CPU. So they all are using the shared memory. So this is how a computer system is organized, and this is what you are seeing. I mean, on this slide, you are seeing the organization. You are weaving the organization of a computer system. Okay, let's go to the next slide. But before the next slide, if there is any question, Walaikum Salam. Another student, he came and said, we are familiar with the BIOS, but couldn't understand it. Okay. Okay, another question. BIOS. BIOS stands for Basic Input Output System. BIOS is also a chip, and you may also think of BIOS as a firmware. There is a chip, and a program has been embedded, or it has been, in simple words, it has been installed on that chip, and that chip is known as BIOS, and all the input and output operations are the basic input output. BIOS stands for Basic Input Output System. BIOS. So all the it is related with all the input and output operation, or input output, how to say, basic input output operations. It is a system of input output operations. This is how we can define a BIOS. Okay. So I hope you would have understood the BIOS as well. Now it is also kind of firmware. Okay. So let's go back to the slide. So computer system operation. Now how computer system operate? Okay. IO devices and the CPU can execute concurrently. We have IO devices, input output devices. IO means input output devices. We have mouse, keyboard. These are a kind of input devices. We have printer, output devices. Scanner, yeah. With the help of scanner, you are normally giving input to the computer system. So it is an input devices. Okay. Mic is an output devices. You are speaking with it. Speakers, sorry, mic is an input device and speakers are output devices. Okay, because with the help of mic, you are giving an input to the mic, so it is an input device, and speakers are output devices. So we have a lot of IO devices connected with our computer system, and the CPU. CPU means here processor can execute concurrently. Concurrently means in different turns they are executing at the same time. So some processes or some tasks they need IO as well as CPU, and they execute concurrently. Concurrently means you may think of to sometimes they execute simultaneously, sometimes they execute in different turns. So in a current concurrent cooperation they normally execute. Okay. Each device controller is in charge of a particular device type. I have already taught this, that for each device type there is a controller which normally controls that device. Each device controller has a local buffer. Yeah, each device controller has a limited memory, and that memory is called buffer. CPU moves data from to memory to from local buffers. Yeah, CPU moves data to main memory or from it takes data from main memory, but by using local buffers or with the help of buffers. You may think of buffers as registers as well. Okay, IO is from the device to local buffer. Okay, IO is from the device to local buffer of a controller. Okay, what does this mean? That IO is from the device to local buffer of controller. Yeah, you know how IO is controlled normally by the controller with the help of local buffers. So the each controller is having its specific limited memory known as buffers. With the help of that buffers, the controller normally controls the IO devices. This is what it means. Okay, device controller informs CPU that it has finished with its operation by causing an interrupt. Yeah, when a device, how a device controller informs the CPU, it creates an interrupt, and that with the help of that interrupt, it informs the CPU that the operation has been performed or it has finished. So it is a kind of alert which is normally given to the CPU. Okay, so this is how computer system operate. Normally, interrupt, and there is another word I have forgotten now. Interrupt and so we have already presently I forgot, but once it comes to my mind, so definitely I will share it with you guys. So we have already studied these things. Okay, so let's go to the next slide. Common functions of interrupts. Okay, what are the functions of these interrupts? I have already taught you these things in the second or first chapter, but let me teach you here as well. But before teaching you this, I would like to go to the comment section. Okay, sir, isn't BIOS and Bootstrap a separate part apart from operating system? Operating system, yes, BIOS and Bootstrap, you may think of them as a separate part, but it will not be easy for them to work without operating system. So BIOS and Bootstrap, these both are programs embedded on chips, and with the help of Bootstrap, normally the kernel is loaded, and once the kernel gets loaded, so then the operating system gets appear on the screen. This is what the function of Bootstrap is. Then the next question is, what sir, didn't understand that second last point. Okay, I will repeat it. Is from device to local buffer of controller. What does it mean? It means that controller for each device. Let's suppose we have printer. Okay, I will go to the slides and then I will explain it there. For each device, the second last point. Okay, IO is from the device to the local buffer. Is from the device to the local buffer of controller. It means that and here the word is the device. So this device can be anything. Either it can be an input device or it can be an output device. And these devices can't operate directly. They operate with the help of a controller, and the controller each controller has its own local buffer. So it means that the IO input output is used normally here for the devices, and the devices can be either input or output, and those devices are controlled by the controller, and each controller has its own local buffer memory. Okay, so the devices, they normally interrupt with the help of controller, and what normally the controller does, the controller, they generate an interrupts. Okay, I hope this time you would have understood. If not, so please, I would suggest you to open a book and to read in detail the interrupt section or interrupt chapters. Okay. Common functions of interrupts. What does this mean? Common functions of interrupts. What normally interrupts do? So interrupts transfers control to the interrupt service routine generally. Okay, interrupt transfer control to the interrupt service. There is a specific service, and that service is called interrupt service. And what normally interrupt transfers the control of any device to the interrupt service routine generally, and yeah, it is a kind of routine normally followed inside the computer system, which always creates different kind of interrupts to inform the CPU or other devices. Interrupt is a kind of alert or information. Okay, I mean, it just informs any specific device through the interrupt vector. Okay, interrupt vector, it is a kind of data structure vector. Which interrupt vector, which contains the address of all the service routines. You know, interrupt vector, it is a data structure which is normally used to store all the interrupts, and for each interrupt there is a specific address which is normally stored inside this vector, you see, which contains the addresses of all the service routines. In a service routine, there may be many interrupts generated by different devices. Interrupt architecture must save the address of the interrupted instruction. Okay, you know, the interrupt architecture or the routine or the service, it should must save the address of the interrupted instruction. Whatever instruction generates the interrupt, so it should must store the address of that instruction which normally causes the interrupt. This is what it means. Okay, incoming interrupts are disabled while another interrupt is being processed to prevent a lost interrupt. Okay, you know, incoming interrupts are disabled. Sometimes the newly coming or the incoming interrupts are disabled, they are pended. Why? Because another interrupt is being processed at that time. Another interrupt is in execution form or is in process form. So that is why we first disable the incoming interrupt, so that to avoid any lost interrupt. This is the lost interrupt. Okay, इसका ये मतलब है कि अभी इस वक्त अगर एक इंटरप्ट जो है वो जारी है, कॉन्टिन्यू है, एक्टिव है, वो क्रिएट हो रहा है, तो जितने भी उसके पीछे और इंटरप्ट्स आ रहे हैं उनको हमें बंद करना चाहिए, उनको फिलहाल टेम्पररी बेसिस पे स्टॉप करना चाहिए, ताकि वो मौजूदा जो एक्टिव इंटरप्ट है इसको डिस्टर्ब ना करे. अगर उन्होंने आके इसको डिस्टर्ब कर लिया तो ये इंटरप्ट क्या हो जाएगा, ये लॉस्ट हो जाएगा, और इस किस्म के इंटरप्ट को हम फिर क्या कहते हैं, लॉस्ट इंटरप्ट. ओके, आई होप आपको समझ आई होगी. मैं जाके उर्दू में पिछला पॉइंट भी आपको समझाता हूँ, जिसमें एक स्टूडेंट ने कहा था कि इसका क्या मतलब है. देखो, ये कहता है इनपुट आउटपुट इज फ्रॉम द डिवाइस